Question number 1 says two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 are thrown. The two scores are noted. The random variable x is defined as follows. If the two scores are equal, x is equal to 0. If the scores are not equal, x is the larger score minus the smaller score. Draw up the probability distribution table for x. So as two dice have been thrown together, first of all we will have to find the possible cases, okay, before drawing the probability distribution table. Let me draw the cases, okay. Well, I have prepared the boxes for this. Okay, they have told that, once again let us have a look at this. If the scores are equal, then it is 0. Actually, if we subtract equal quantities from each other, it is 0. Or score will be the larger one minus smaller one, that is subtraction. Simply it is subtraction. So let us see. If we subtract, it is going to be 0. If we subtract, it is 1. It will be 2, 3, 4 as well as 5. For the next one, if we subtract, it is going to be 1. If we subtract, it is 0. If we subtract, it is going to be 1. Then 2, 3, 4 as usual. Then if we subtract, it is going to 2. It is going to be 1. It is going to be 0. Then 1, 2, 3. You can easily write. Then it is going to be 3. It is 4. It is 5. Again 2, 3, 4. Then it is 1, 2, 3. Then this is 4 minus 4 is 0. Then 5 minus 5 is 0 and 6 minus 6 is 0. So 0, 1, 2, then 2, 1 and 1, then 0 and this is 1, this is 2. So 5, 4, 3, 2, 1, 0. So that's are the possible cases. Now we will have to know how many zeros are there, how many ones are there, how many twos are there. So we can write here, if we write x is equal to 0 when x equal to 0, when our probability p of x is equal to x, sorry, when x equal to 0, okay, then it is going to be, sorry, not 0, it is x, lowercase x is equal to, look at this, how many zeros are there. If we see straight away, there are 6 zeros, 1, 2, 3, 4, 5, 6 zeros. So it will be 6 and total number of probability, I mean outcomes, is 36. Okay, when x is equal to 1, then our probability is going to be x. Let's see how many ones are there out of 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. Are there 9 ones? Let me count once again. One with different ink. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ones. So it is going to be 10 over 36. 10 over 36. Well, then the next x value, our x value is going to be what? When x is equal to 2. When x is equal to 2, our probability is going to be, so how many 2's are there? Let's count. So 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 2's. So 8 over 36. Then if our x takes the value of 3, when x is equal to 3, then our probability of x It is 36 on 36 and it 3. So how many threes are there? So 1, 2, 3, 4, 5, 6. There are 6 threes. Okay, as I do not have space over here, I think I can write just on the left side. Okay, so on the left side, when x is equal to 4, x is equal to 4, then when probability is going to be probability of x, let's see how many 4s are there. How many 4s? 1, 1, then 2, 3, 4 4s. How many 4s are there? Total 4 4s. And how many 5s are there? 1 and 2. There are only 2 5s. Okay, so 4 and 2, the next two probabilities, 4 and 2. So it is 4 out of 36, 4 fours, and 2 fives, 2 out of 36. Well, when x is equal to 5, our probability is going to be 2 over 36. So that's all about our probabilities. Now easily we can write our probability distribution table. Let me write probability distribution table here. In words, I will write here probability distribution table. Probability probability distribution table. Probability distribution table. Okay, first of all I will prepare the box. Let me draw the table. Yes, so the table will look like this. Okay, this is our table. So on the upper box x, and it is x is equal to lowercase x. So what our probability? 0. What are the numbers? X takes the values of 0, 1, 2, 3, 4 as well as 5. So for the first one, let us go back to our probability. When x is 0, our probability is going to be, what is our 6 over 36. So if we write 6 over 36, 6 over 36 is equal to how much? If we divide 6 by 36, it is going to be 0.167. So 0.167, 0.167, the first one we are expressing in a decimal. Then 10 divided by 36 is 0.278, 0.278. If we divide 8 by 36, it is going to be 0.222, 0.222. Then if we divide 6 by 36, it is going to be 0.167, 0.167, 0.16 and 7. Then the remaining two probabilities, when x is 4, our probability is going to be what? When x is 2, probability 2 over 36 is 0.056, 0.05 as well as 6. And when probability is 4 over 36, it is going to be 0.111, 0.111. So we will just insert these values in our box. So let's start writing there. The first one is, first three probabilities are what? 0.167, 0.278, 0.167, 0.167. Then second one is So this is our probability distribution table of these 6 values of x. Now let's move on to the immediate next question. Let me write this number. So this is whole of our solution to the first part of the question. Okay, then the next one says find ex and variance of x. That means expected value, I mean mean. First of all, they have told us to find the mean, I mean ex. And we know ex is equal to ex. Let me change the color of the ink. It is ex, and we know ex is actually mean of the value. So how can we find the mean? Our denominator in all cases is 36. Look at this, it is just 36 in every case, 36. Okay, so I think I can explain this a little more by this. Ex is equal to sum of that is mean value, sum of x into probability of x. That means we will multiply each of the probability by x and we will do addition. So in all cases the denominator is 36 if you see, because total number of outcomes is 36. Okay, now if we multiply by x, here x is 1, sorry, first one is x is 0. By 0 if we multiply it is going to be 0. So 0. Then by 1 if we multiply 10 it is going to be 10. Then by 2 if we multiply 8 it is going to be 16. After that x is 3. By 3 if we multiply 6 it is going to be 18. Then our x is 4. If 4 multiplies 4 it is 16. Finally our x is 5. If 5 multiplies 2 it is 10. So totally our ex mean value is how much? 10, 6, 26, then 44, 60, 70. So it is 70 over 36. If we round it up to three significant figures, I mean in decimal fraction, it is going to be, let me write in decimal point, 70 divided by 36. 70 divided by 36 is equal to, let us use our calculator, it is going to be 1.94. 1.94 is our mean value. Then they have told us to find the variance. Okay, how can we find variance? Variance is equal to variance of x. Variance of x is equal to ex square. Variance will come later on. First of all, let us find e of x square. So ex squared. Ex squared is equal to, the same way it will be, let me expand one more step, that is sum of x square into each of the probability x equal to x equal to, okay, equal to, now we are going to write in this case also denominator is 36 in each case. Okay, so 36, if it is 0 square, if we made x square, so 0 square means 0, so first one is 0 as usual, and the second one is 1 square, so 1 square into 10 means 10. Then the second one is 2 square. 2 square means 4, 4 8s are 32. 32 plus third one is 3 square means 9. So 9 sixes are 54. 54. After that 4. So 4 square means 16. 16 fours are 64. Plus next one is 5 square means 25. Twos are 50. So this is 50. Hence our ex square is going to be 36, and if we add up all of this, so 2 4 6, 6 4 10, this is 10, and 1 5 6 12, 17, 20, 21. So 210. We have got ex square, but that is not the final answer. For final answer, we will have to write a variance. Okay, let me write on the left side. On the left side, we can write variance is equal to variance of x equal to ex squared minus whole square of mean value. Okay, so mean value is ex square is what? Just we have found here ex square is 210 over 36. So we will write 210 over 36 minus ex whole square is, sorry, ex whole square is 70 over 36. So 70 over 36, 70 over 36 squared. Let me draw a division line. Okay, then it is going to be, let us use our calculator, 210 over 36 minus 70 over 36 whole squared. It will show 2.05 2.05 is our variance. So that's all about the finding probabilities of each of the values, then finding expected value as well as variance. Expected value and variance is 2.05 is the final answer. 2.05 is our final answer, and variance is actually expected square of expected value minus mean square. Mean means ex whole square. If I draw a black line, yes, as there is the shortage of space, the digits may be very clumsy and congested, yet I explain every tiny part, so I don't think that it will be very difficult for you to understand, and it is one of the most usual and easiest questions. So thank you all for being with me, and may Allah bless all of the students with beneficial knowledge. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve two questions from Probability and Statistics 1. And this two particular question belongs to paper 9709/55 for the session May June 25. The first question 2, which is the heights of trees in a certain forest are classified as tall, medium, or small. The heights can be modeled by a normal distribution with mean 20 meter and standard deviation 5 meter. Trees with a height of less than 14 meter are classified as small. For 150 randomly chosen trees from this forest, how many would you expect to be classified as small? So in the first question, it is expectation, and we know expected value means actually mean. So we will have to find mean, and mean is the product of n and p. That means total number of trees into probability. So let us find the probability. Then let us write x belongs to normal distribution. Okay, it is already written that normally distributed. Then for normal distribution, the parameters are what? Mu and variance. Mu is mean. Mean and variance. Mean is 20 and variance is the square of standard deviation, that is 5 square. So these are the two parameters for normal distribution. One is the mean value and the other one is the variance. Well, now we are going to find the probability. So probability of what? X is less than 14 meter. Okay, so x is less than 14 meter. X is less than 14 meter. Okay, so after that, we will have to standardize this score. Z less than 14 minus mu. Mu is 20 over standard deviation. Over standard deviation. Standard deviation is 5, already given in the book. Then if we subtract this, it must be negative. Z is less than negative. It is going to be 6. If 6 is divided by 5, it is definitely 1.2. 1.2. Well, now through a graph, we will see what is the condition of the probability. So this is our normal graph. Okay, in this normal graph, if we look, normal graph is always symmetrical. Suppose this is 0 and our standard deviation is negative 1.2. Let me rewrite this, negative 1.2. That means z is less than 1.2. That means this is left part, less than 1.2. So this portion is our probability to be obtained. Okay, so for this, actually none of the probability to the negative corresponding z-score is given in the normal distribution table. That's why what we will do, so we know that this portion is our requirement. Okay, negative 1.2. And as the normal distribution graph is always symmetrical, so this portion here it will be 1.2, and our necessity of probability is this region. Okay, so for this region, definitely this region and this region will be exactly same, because normal distribution curve is symmetrical. Well, now the question is, how can we find this one? What we will do is, we will find the probability of the left part, all of this from whole of the probability. Whole probability means 1. From 1, if we subtract this left part, I mean blue shaded part, shaded in blue, the left part, from whole probability, if we subtract this left part, we will surely get the right tiny red part, I mean blue part. If blue part is subtracted from whole of the probability, we will find this red part, and definitely this tiny red part is exactly as same as this part, this part. Okay, so this part and this part are exactly same. So what did we do here? We have just shifted the negative z-score to the positive z-score. That means right side of 0, mean value. Here it is mean value, and we know that the normal distribution graph is symmetrical. Well, so for this, what we can do, we are going to write here probability of z less than negative 1 is from 1. Whole probability, total probability is always 1. From 1, if we subtract the left part, so for left part we will write z less than 1.2 instead of negative 1.2. I think you got my point, that 1.2 is positive now, because there is no probability given in the probability distribution which is applicable for any negative z-score. So it's all about positive z-score, and probability is always more than half, so we will have to choose this. Then we are going to write 1 minus when probability of z is less than 1. Let's find the corresponding probability. For that, I will have to collect this image. is our requirement. Yes, over here, not over here, on the other page. Let us find over here. No, not there also. Let us take a new page. Okay, then in the new page, on the new page we will, okay, this is our new page. Then we are going to find our normal distribution table. Okay, so normal. So from this one, what we will do, we will find our z-score. Our z-score was 1.2. Let's see where 1.2 is given. Means 1.20. Okay, let me mark with red ink. So 1.2, I can show you here. 1.2 is over here. Look, 1.2 and 0. Okay, this one. So row is 1.2, column is 0. That means directly this is our probability. So our probability is 0.8849. I think you have got my point. Our z-score was 1.20, and you can see here nowhere it is written that negative z-score. So this probability distribution table is always given for positive z-score. That's why we have found, we have converted the negative z-score, shifting it to the right side. Okay, so a 0.8849, 0.8849, point, let me change the color of the ink, 0.8849. Then if we subtract 0.8849 from 1, it is going to be 1 5, then again 1 1 point. Okay, so it is 0.1155, then 1 1, 1 and 1. So 0.1151 is our probability. We didn't forget that the question has told us to find not probability. Look at this, is expected value. We are supposed to find expected value. So Ex is equal to, we know, I can write over here Ex. Ex means actually mean value. How can expected value means actually mean? How can we find mean? Mean value is total number into probability. Ex is equal to, no, let me write just beside this. Okay, so our total number of trees is how much? 150 randomly chosen trees. So 150, and our probability for each tree is 0.1151, 0.1151, 0.1151. Then finally, if we multiply this, it is going to be, 17.265, 17.265. Now they have told us to find number of trees. Number of trees cannot be actually in fractional. So there are two possibilities. If we round it up to three significant figures, it is going to be actually 17 trees. But in another way, if we consider that, look at this, more than 17 trees. It means more than 17 trees. It's actually 18 trees. So 18 trees is the probability. We will have to write it in, trees cannot be fractional. Remember, number of trees is always in whole number, integer. So if we convert 17.265, you can write either 17 trees or 18 trees. According to me, actually it means the mean value is more than 17. So more than 17 means it will be 18 trees. Well, let's move on to the immediate next question. The immediate next question says, trees of this forest are classified as tall, if their height is at least h meter. 25% of the trees are classified as tall. Find the value of h. So following the previous solution, we can solve it easily because we are still under the same normal distribution. So for normal distribution, we know x belongs to normal distribution and the parameters are what? Parameters were mean was 20 and our variance was 5 square, means standard deviation was 5. Now they have told that probability of x is, look at this, at least, that means their height is at least h meter. Okay, so at least what does it means? It will be either more than or equal to h meter, and the probability is given 25%, means 0.25. I think you have understood as I have written here. They have told height will be at least h meter, so it may be greater than h meter or equal to h meter. Now we are going to standardize as we did in the previous case. It is going to be probability of z score. Z is greater than. Now here you may ask a question. Instead of greater than an equal symbol, actually normal distribution graph is always continuous. So for continuous value more than h or equal to h, this is right side. So it's all the same actually. Then h minus our mean value is 20, then it is 5. Right side is 0.25. So please don't get confused with this equal symbol. It's greater than or equal to is actually means same in case of normal distribution, because this is applicable for continuous random variable. Now we will have to find the corresponding z score when the probability is 0.25. Now look at this. This is our graph. Okay, in the normal graph, yes, our probability is 0.25. From left side, if we start, 0.25 is very meager because here this is 0.5, half of the whole graph. So 0.25 may fall over here. Look at this. This is our probability because it's very tiny. Okay, 0.25, and here z score is what? H minus, here let me write here 0.25 with different ink. This is 0.25, that is 1/4 of the whole graph. Now this curve is definitely similar to this portion. Look at this red shaded region and blue shaded region must be equal because the graph is symmetrical. Now what will it be? As it is, our z score is, look at this, original probability is lying on the left side. Okay, so z score is here. It must be h minus 20 over 5. So this point of z score is this. Okay, and here it is going to be h minus, it must be negative. Okay, so we will have to write negative. Sorry, I made a little mistake. It is not less than, it is actually greater than. So not the left part, it will be right part. Let me draw once again. Our probability is lying right side of the z score, so it is 0.25. So 0.25 is this portion, not this portion at all. It is over here. So this tiny part is actually 0.25. Okay, now what we can do, that means where is our z score lying? Our z score is lying over here, h minus 20 over 5. Okay, this is our z score. So this portion is our probability, but we know that in probability distribution table none of the probability is less than 0.5. All the probabilities given is more than 0.5. That means this portion. So what we will do, we will find this one. If this is 0.25, this is 0.25. Okay, this portion is 0.25. Let me write once again. This portion is 0.25. 5. So what will be the left part? Surely this black inked, I mean black shaded part, dark part must be 0.75. I think you got my point. Look, we are not making any change to our z-score. Z-score is as it was. So this black part, dark part is our probability. As for 0.25, we cannot find any z-score because all the probabilities in the normal distribution table is more than zero point 0.5, and this portion is actually 0.75. So we can easily find the probability of 0.75 when the corresponding z-score is h minus 20 over 5 and it is lying on the right side. So it's definitely positive. Okay. So let us find the probability of 0.75. Once again, I am clarifying, we cannot find for 0.25 because none of the probabilities given in the probability distribution table is less than zero point 0.5. So let me show you from the graph. Yes, over here. From the same graph, if we see here, let me erase this after zooming it out. Okay. Look, none of the probability, the first probability started with what? 0.5. Look, so all the probabilities are more than 0.5. That's why we have chosen more than 0.5. I mean, alternated way. Instead of 0.25, we have found the probability of 0.275. Okay, now let's see what is the correspond. We require actually probability, not z-score. So for z-score, we will have to take one more worksheet. Let me see. Does it have the lower part? Lower part is not clear over here. I am going to show you from the next image. It is normal distribution. First one. Yes. Not on this page, on the next page. Yes, over here. Over here, if we, yes, this is the lower part of the same table. Our probability is 0.75. Look at this at the bottom of the page table. When probability is 0.75, our z-score, corresponding z-score is what? This is our probability 0.75 and corresponding z-score is 0.674. So we are going to write 0.674. We are not searching for probability. Already we do have probability. That's why we are going to get the z-score. So our z-score is 0.674 and I have already shown why have we taken 0.75 instead of 0.25 because none of the values is 0.5 in the probability distribution table. So 0.674, let us write 0.674. Okay, so our z-score is 0.674 when probability is 0.25. Now please don't get confused, as I have told, it is going to be 0.75 because point z-score doesn't get changed whether it is 0.25 or 0.75. Our z-score is same. That's why probability will not be different. According to z-score, its greater part is 0.25. Well, so look at this. Here we can write hence h minus 20 over 5 is equal to same. This one is z-score. Look at this one is our z-score, okay, and hence this one is also our z-score. So they must be equal to each other, because for the same probability z-score must be equal. So 0.675. No, I will have to change the ink. 0.675. After that, what we will do is h is equal to h, or h is equal to by 5. If we multiply, it is going to be 5 into 0.675, and if we transpose 20 to the other side, it is going to be plus 20. Hence our h is equal to 5 into, let me use my calculator, 5 into 0.675, 375 plus 2, so it is 23.37. So if we round it up to 3 significant figures, it is going to be 4. So that is what our value of h is. I think you have understood this. And from the solution number 2, you have learnt that for any probability which is less than 0.5, we will find for the alternated one. Always the probability given in the normal distribution table is more than 0.5. That's why always z-score remains same, because z-score just shows the left side or right side. Okay. So as if we require left side small part, always we will find the probability which is greater than 0.5, and corresponding z-score must remain same. Then let's move on to question number 3. Question number 3 says yes, it is 3. In a certain large school, on average 2 pupils in 5 have music lessons. A random sample of 80 pupils from this school is chosen. Use an approximation to find the probability that fewer than 27 pupils have music lessons. Okay, so still we are under another normal distribution. So let us write that normal distribution x belongs to, not with this ink, x belongs to normal distribution, and the mean value is what? Look at this, we will have to find approximation. For approximation, always it means, sorry, it is not a normal distribution given. Actually, we'll have to turn it into normal distribution. Look, approximation is the clue word over here. Whenever the word approximation mentioned, it means the distribution is given in binomial distribution, which is to be converted to normal distribution. So for binomial, we know the parameters are x belongs to binomial, and we know the parameters of a binomial distribution is n and p. N is 80 and probability is what? 2 peoples in 5. So 2 over 5. 2 over 5 means how much? 0.4. Okay, then if p is 0.4, our p is equal to 0.4, then q is going to be zero point 0.6. Okay, q is going to be 0.6. So our probability of having music lesson is 0.4. The probability of having no music listen is 0.6. So it is going to be zero point 0.4. Probability is zero point 0.4. Then for approximation, what will we do? We will just convert this binomial distribution into normal distribution. So x belongs to normal distribution, and for normal distribution the parameters are mean as well as variance. Mean is n into p. If we multiply n and p, it is going to be 32, and our variance is npq. So 32 into 6, I mean it is going to be 19.2. 192, that means 19.2 is our variance. Well, then they have told us to find the probability of x less than, look at this, what is this, to find fewer than 27 pupils. Okay, so we will write less than 27, but remember we are converting a binomial distribution into normal distribution. Binomial distribution is always applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So we will have to do continuity correction. If 26 is uh, corrected with continuity, it is going to be, it is less than, so less than 27 means it is going to be 26.5. okay, remember, don't get deviated from this point. Whenever you convert a binomial distribution into normal distribution, you must not forget, let me write here another n, you must not forget to do continuity correction. Okay, well, now we will standardize the score as we did in the solution to question number 2. Then z is less than 26.5 minus mean value. How much is our mean? Our mean is 32. 32 over standard deviation. Standard deviation is always square root of the variance. Square root of variance. Then probability of z less than, look at this, as we are subtracting smaller numbers, so definitely it is going to be negative. So z less than negative. Okay, it is going to 5.5 over 19.2. 5.5 over 19.2 is 1.255. 1.255 is our negative z score. Well, so how will our curve look like? Well, our curve will look like this is 0. As our z score is negative, so it must lie on the left side. Okay, it is over here, 1 point negative 1.2. So less than negative 1.255, which part is our probability? This region, red shaded part, is our probability. Okay, these probabilities to be obtained. So for this, how can we find this portion? We will look at this. This is the another part. Okay, this another part. From whole probability, if we subtract this right side, okay, though right side cannot be subtracted, we will find the probability if we subtract the larger part. Okay, let me show through another graph, it will be easy to understand. Okay, I'm drawing one more graph which is exactly like this. So suppose this is the another graph. So we require the red shaded part. Okay, so red shaded part can be over here also. Look at this portion, because the normal distribution graph is always symmetrical. So red portion we have shifted to the right side, and black shaded part is this part. Okay, so what will we do? We will, from whole of the probability, will just subtract this, and our z score will be shifted now on the right side. And look at this, all the z score lying on the right side of 0 mean value or mean line, it must be positive. So here 1.2 is our z-score. It's no more negative because the probability distribution table provides the probability of corresponding positive z-score. There is no negative z-score in the probability distribution table, but it's all the same. As I have told, it is actually this red shaded part and this red shaded part in both the figure is exactly same. But as for negative corresponding z-score, there is no probability is given. We will try to find the positive z-score, and hence it is going to be from whole of the probability. Look, whole probability is 1. From 1, if we subtract probability of z less than 1.255, it will be exactly same because the shaded part is same, as you can see. Now let's see the z score, I mean probability, corresponding probability when z score is 1.255. From the graph I can show you. Let me go to a new page. Yes, here. Then we will find our normal distribution table. Yes, not from this, from the whole, the larger one actually. Yes, this larger one. So from here, let me zoom it out. Let me. Well, our z score is 1.255. So let us say this is 1.2 and then 5 is over here and row is this. That means this is our probability. Okay, then another 5, 1.25, then another 5 is over here. This is 5 and our column is this. No, not this one, the third one. Okay, so 1.8944, if we add up this 9, it is going to be 53.8953 is our corresponding probability. And let us write over here. So our corresponding probability when our z score is 1.255 is 0.8953. 0.8953. After subtraction, we are going to get, if we subtract this, it is going to be 0.1047. This is what our approximated value. So what have we learned from here? We have learned two parts. One is whenever approximation word is mentioned, then we will have to convert the binomial distribution into normal distribution. Okay, and in normal distribution, if our z score is negative, we will shift it to the right side when it will be positive. For that, if we require tiny part as probability, suppose this part, if we require the tiny part, I mean this part, these two parts are exactly same. Just for this tiny part, always we will subtract the greater part from 1, whole of the probability. That's what we did here. We have subtracted the left part, I mean greater part, from whole of the probability, then we got this corresponding probability. Let's move on to the immediate next question. Question number B says a random sample of 10 pupils from this school is now chosen. Find the probability that no more than 2 pupils have music lessons. Okay, so this is, look at this, this is simply a binomial distribution. So we will write x belongs to binomial distribution, and for binomial distribution the parameters are n and p. Number of total pupils is 10 and probability of having music lesson, we reused it as 0.4. Okay, now they have told us to find the probability of x less than no more than 2 pupils. That means maximum there is to be either less than or equal to 2 people. That means we'll have to find when probability there is no x equal to 0. That means there is no music lesson. Then sorry, there is music lesson if there is no people. Then if there is only one people who has music lesson, or if it is when only there are two people, no more than two people. So either there may be no person or no student has music lesson, or only one student has music lesson, or two students have music lesson. These are the possible cases for this probability. So when probability is 0, x is 0, that means none of the people has chosen music class. So that means all 10 people chose for non-music class. So the probability is total is 10, 10 choose 0, none of this. So probability is 0.4, none of this. Okay, none of this, all 10 has chosen, that means q raised to 10, because all 10 are out of music class. Okay, when there is only one, so out of 10 there is only one student who chose music class is 0.4 probability, only one. Then rest of the nine student didn't choose music class. After that, let me zoom it in. After that, there may be only two students out of 10, two has chosen music class. So for music class probability is 6. Rest 8 student didn't choose music class, so for them probability is 0.6 raised to 8. Let us do this calculation here. From 10, if we choose no one, only there is one way to choose one. So and 0.4 raised to 0 is also 1. So it's actually 0.6 raised to 10 plus. From 10 student, if we choose only one student, how many times we can choose? 10 times. 10 using calculator you can do this, but manually I can explain that 10 choose 1 means actually 10. Okay, because if you choose 1 out of 10, how many ways you can choose? How many times? 10 times. Okay, 10 into zero point 0.4 into 0.6 raised to 9, 0.6 raised to 9 plus 10 factorial, 10 into 9 into 8 factorial over 2 into 8 factorial. If you expand this, you can write in this way. And 0.4 two times. So two students choose music class. So it is 0.4 two times. 0.4 two times and 0.6 8 students. 0.6 8 student. Now if we calculate this, what is it going to be? 8 factorial can dissolve each other, and 2 can dissolve this 10, it is going to be 5. Okay, so finally it is going to be, let me use my calculator, 0.6 raised to 0.6 raised to 0.6 raised to, okay, it is 0.6 raised to 10, 0.6 it is going to be 0.16 and 7 is the probability that maximum 2 student who chose music class. So that's all about the solution to both of the questions, question number 2 as well as, let me show question number 2. Question number 2 is on this page. 2a as well as b, both of them belong to normal distribution, and I try to explain every tiny part so that you can understand it easily. And then our question number 3 is over here, which is simpler actually than the solution to question number 2. So it is in 3. First one was normal distribution, whereas the final one was binomial, simple binomial distribution. So let us take leave, and thank you all for watching the video. May Allah bless us all with beneficial knowledge. Well, the immediate next question says students applying to Drydale College take an entrance test. A student is either accepted or rejected or required to take another test with probabilities zero point 0.3, zero point 0.2, and zero point 0.5 respectively. When a student takes a second test, the outcomes and probabilities are exactly the same as for the first test. A student who has to take a third test is accepted with probability of 0.25 and rejected with probability 0.75. Draw a tree diagram to illustrate this information showing all the probabilities. Well, so the question seems to be very complicated and large, but the solution is not as difficult as it seems to be. So let us draw the probability diagram, tree diagram. Okay, so for the first test, it is, there are three possibilities. The candidate may be accepted or he may be rejected, and if rejected then he will have to take for the next test. So acceptance or acceptability probability is 0.3. If rejected, the probability is 0.2. If he needs to take a retest, then it is 0.5. When someone is supposed to take the next test, then again there are three possibilities which are exactly same as the first test, either accepted or rejected or retest. So for acceptability probability is 0.3, for rejection probability is 0.2, and for retest the probability is 0.5. Then in third case, if someone attends two tests back to back, then he has only two possibilities, either he will be accepted or rejected, and the probabilities are 0.25 or 0.75. So this is the tree diagram of the probabilities. Okay, then let's move on to the immediate next question. The next question says find the probability that a randomly chosen student who applies to Drydale College is accepted. Okay, for acceptability actually there are three possibilities. Okay, he might be accepted in the first test, in the first attempt, or he needs to take the second test, or he might took the third test. Well, so let us write probability of acceptability. It may be in the first attempt, second attempt, or third attempt. Probability of, we will write here, probability of acceptability. Okay, acceptability, acceptance. Let us write acceptance equal to, he might be succeeded in the first attempt, so probability of acceptability, or he took the first time he failed, I mean he was required to take the second test, so first one was retest and second time he got succeeded, or in the first two times he were given two chances and in the third attempt he was accepted. These are the possible cases. So if someone is accepted, the probability is what? 0.3. First acceptability 0.3, or first time he failed, I mean he was attending the second test, so first retake was what? For to first T it was 0.5, 0.5, 0.5, but second time he was accepted. For acceptability, our probability is 3. Or back to back first two times he needed to take the second test to participate the second test. So zero point 0.5 first time retest, second time also retest, third time he was accepted, and probability of acceptability is 0.25. For the third time it is 0.25. Let me write this with erasing this. Let me erase this. So it is 0.25 for the third success, third time 0.25. Okay, then if we calculate all of these, it is going to be zero point 0.3 plus this 0.3 plus this is 0.15, 0.15, not 3 we will take, okay, 0.15, or it is going to be 25, 25, 625, 0.0625. Okay, so the final digit is 5, definitely it is going to be 5. Then the next digit is 2. After that there comes 6. 6 and 5, sorry, it will be 7, I think. No, it's all right. So two digits. Then 6 and 5, it's 11. So 1 is carrying, so 1, 1, 2, 2, 3, 5. 5. Before that there is decimal point. So if we round it up to three significant figures, it is going to be point 0.513. Okay, this is what the probability of the second question is. So that's all about the solution to both of the first two parts. Let's move on to part C. Question number C is printed on the next page. Let's see what it says. It says find the probability that a randomly chosen student who applies to Drydale College takes at least two tests given that the student is accepted. So first of all, what will we find? We will find that he was accepted. If someone is accepted, the probability is written as 0.5125. So let us write probability of acceptability. As we have already found in the previous question, probability of acceptability of a student is over here. How much it was? 0.51. This is 0.5125. 0.5125. So we can easily write it 0.5125. 0.5125 is the probability of acceptability of a student. Okay, then we will find probability of acceptability of student. Two tests. Okay, second test intersection accepted and accepted. Well, then what are the possible cases? Probability of second test and then it was accepted. That means at least two tests. So it might be first time he failed. Okay, I mean he took the second test, I mean second chance. So first it was probability of t, then he was accepted. This may be the first case. Or he was first time it was t, that means he needed to take the second test. Second time also he needed to take the test first time and second time, and third trial, in the third chance he was succeeded. So let us see, probability of t was zero point 0.5 and probability of acceptability was 0.3 plus, so two times he failed, and not failed means he was given the second and third chances. So zero point 0.5 probability of t into zero point 0.5 probability of t, and acceptability in the third test is 0.25. 0.25. I think you are getting my point. Second test and accepted. Look at this. So find the probability that randomly chosen student who applies to Rydell College takes at least two tests. At least two tests, given that the student is accepted. That means at least two tests. Test mean he was given the first chance and then second time he succeeded. So first one was T, second one was accepted. Or it was given that first time he was given a chance, second time also he took the chance, and third time he was accepted. So first two T's and then accepted. So it is going to be 0.15 plus it is 0.0625. If we add up, it is going to be four digits. Okay, 0 and 0. So 1500 and 625, it is going to be actually 2100 625. It isn't it 2125 0.2125. Well, now they have told us to find that, then we can write p second test. Okay, how to write this? P second test given that, this is given that symbol accepted is equal to p second test intersection accepted over probability of acceptability accepted. Okay, so we have already found all supporting information. When second test intersection accepted is how much, we have got it 2.2125. Sorry, it is yes, 0.2125. It is going to be this one. Second test intersected by accepted is 0.2125. Then probability of acceptability is this. Probability of acceptability without any restriction is 0.5125. Then what will the answer be? Let us do this division. Equal to, we can use our calculator, 0.2125 over point 0.2125 over 0.4146 equal to 0.4146. If we round it up to three significant figures, it is going to be 0.415. I think you got my point how to solve this. So whenever such question given that is the condition, first of all we will find the letter probability of letter 1, that is accepted. Then we have found accepted and second test, the intersection of these two. After that, it will be the second test intersected by accepted. It will be divided by, if it is accepted without any restriction. Without any restriction is actually this accepted after this probability has been obtained from the solution number B. If a randomly chosen person is accepted, the probability is 0.5125. Then if he was supposed to take second test and then accepted, it is actually second test intersected by accepted. And I have explained here how to find this value. Well, let's move on to the immediate next question. The next question says that three friends apply to Drydale College, find the probability that all three are rejected. So it is actually, first of all we'll find the rejection of one person. So probability of one person, that is rejection. Probability of rejection. We have seen that there are three cases. Let me write just below this. Suppose first time he was rejected. So as there are three possibilities, he might be rejected in the first case, or he might be given the second chance. So first T and he was given that the second chance, but he was rejected, or he was given two chances, first test, retest, and again he was rejected. This is the probability of being rejected of one student. Okay, this is for only one student, but as there are three students, so what will happen? Three times it will be just q. Okay, so let us see what was the rejection of the first case. For rejection in the first case, it was 0.2, isn't it? Let us get sure. Rejecting in the R is 0.2, second one is also 0.2, third one was 0.75. Okay, so it is 0.2 plus first probability of taking the retest is 0.5, then rejection was same 0.2 plus first one was retake 0.2, not 0.2, it was 0.5, sorry, it was 0.5. Second one was also 0.5, that means retest. Third time he was rejected, and the possibility of being rejected for the third time it was 0.75, because acceptability was 0.25, 0.75. Now if we sum up this, let us do this calculation. It is zero point 0.2, then how many zeros are there? We can take four zeros. 1, 2, 3, 4 digits, because here it is going to be, or let us do the calculation easily using our calculator. Okay, so first one was zero point 0.2 plus 0.10. 0 0.2 0.2 plus 0.10, it was 0.25 into 0.75. 0.25, 0.25, 0.25, six. So our probability is 0.116. I think you got my clarification, because as we will have to multiply, I mean it is three times, because for one student the probability was that, so for three students means three times it is being happened. 3 cube. There is another simple way to solve this, which is, look at this, or probability of A, probability of acceptability was what? Point, probability of acceptability we have already written here. It is 0.51, 0.51, 5125. Okay, then probability of rejection is going to be, if we subtract from 1, it is going to be 1 minus, so 5125, that is 4875. 4875. So this is for probability of rejection. But as there are three student, okay, so it will be just cube. If we use this cube, then it is going to be, let us see, 0.4875, 0.4875, 0.4875 is also another shortcut way. It is going to be 0.116. So these are the two ways you can apply to solve the final question. That's all about the solution to all of the parts of this question. First one was tree diagram, second one was acceptability. So for acceptability there are three possibilities, three times, because first time retest, second also retest, and third time he might be accepted. And for question number C, it is the most important question. Look at this, it is given that. So for given that, I have already explained how to do this. For D, actually this is rejection. In rejection, it may happen in the first case or second case or second test or third time. As there are three children, I mean three candidates, so it will be actually not three times. Remember, we are not doing addition. As there are three candidates, so it will be cube. Don't get confused with multiplication. You cannot multiply by 3. So thank you all for being with me. Allah Hafiz. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1, and this particular question belongs to paper 9709/55 for the session May June 25, and we are going to solve one of the easiest and simplest questions of this paper, which is number 5. Let's see what it says. The Smarts and the Teasers are two quiz teams that each contain 11 members. Both complete a puzzle, and the following table gives the times taken in minutes by the members of each team. Represent this information in a back-to-back stem and leaf diagram with Smarts on the left-hand side. Well, we are going to draw a stem and leaf diagram. For that, we will have to draw. Smart should be on the left, okay? So this is on the left side, there will be smart. Let's write smart over here. Smart. And on the right side, there must be the teasers, okay? Teasers. Smarts. Well, then for writing back to back and stem and leaf diagram, always we start with the lowest value. So let's see, the lowest value is here 9. This is the lowest value, so it starts with 0. Then 1, there are 2, 3, 2 as well as 3, 3, and 4 is the maximum value, okay? Well, now we will put the values, okay? Let's see what are the values for smarts. First value for 0 is 9 second, 9 minutes, 9. And after 1 there comes 1 3 8 8, 1 3 8 as well as 8. Then after 2 there comes 22 28 29. So 2 8 9, 2 8 as well as 9. Then after 3, beside 3 there will be 30 and 38, okay? 30 as well as 38. After that there is, after 4 there is only 1 is the maximum value. Then for teasers minimum value is not 1 digit, it's 2-digit value. So minimum value is 258. 258. We can use even different ink for the teasers. 2 5 as well as 8. Then after 2 it is 21 25 25 two times, okay? 21 25 and again 25. Then after 3 it is 2 6, I mean 22 26 27 29 29, okay? 2 6 7 9 as well as another 9. And after 4 integers, actually there is no time given beyond 40. So this is what our box, sorry, back to back and stem and leaf diagram. Now we will have to show the key, okay? Let us write the key of this stem and leaf diagram. Key is equal to, let us close this box, okay? So our key is going to be, suppose we are choosing this 3 in the middle, 0 on the left side, and 2, shows that, we are going to explain what it shows that time taken by the smarts is 30 second 30 seconds, whereas 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 time taken by time taken by the teasers is equal to is how much? 32 seconds. 32 seconds. So that's all about the answer to this part of the question. Let's see, it is simply we can write this box sorry, stem and leaf diagram. So let's see what the next question says. Next question is on the next page. Okay, so first of all, let us read the question. The question says, for the teasers, the values of the lower quartile, median, and upper quartile are 18, 25, and 37 minutes respectively. On a single diagram, draw box and whisker plots of the two teams. Okay, so for remember, we should not forget that for box and whisker plot, there should be 5 information for required for each of the team. What are they? Let us write all of the 5 informations. First one is the 5 information. Okay, first, smarts. For smarts, the 5 informations are: number one is lowest value, lowest or least, whatever you tell. Then lower quartile, quartile 1. Then median or quartile 2, whatever you tell, median. After that, upper quartile, quartile 3. Then maximum. So total there should be 5 information. Then for the for teasers teasers also we will find 3 information, sorry, 5 information. First one is least or lowest, whatever you tell, lowest time. Then second one is lower quartile. Then median, it is median. Then there comes upper quartile, third quartile, and last of all it is maximum. So these information are required for us to draw a box and whisker plot. Let us see what are the lowest value, lowest quartile 1, upper lower quartile, median, and quartile 3 of smarts. We'll have to go back to the previous page. On the previous page, our lowest value is 9. This is the lowest for smarts, lowest. Then lower quartile, that means total number of members in each of the team is 11, so there will be total 12. We'll have to count as 12. So 12, if we divide 12 by 3, then 12 by 4, it will be lower quartile. So 12 divided by 4 is 3, so third position. This is quartile 1. Okay, then second, third position, I mean sixth position will be the median. So third, fourth, fifth, sixth, this is our median. Remember, you must start your counting from the left side. From here, your counting should start from the line, not from the further away. Okay, from here you will have to count. Okay, we are counting smarts. So lowest value is 9 minutes. Then quartile 1 is 3 minutes, and the median is 2 minutes. Now upper quartile. So upper quartile is another 3 position you will have to proceed on. So 1, 2, 3. Upper quartile is 30 and maximum is 41. So all 5 information has been obtained from here. So 9, 13, 9, 13, 22, 30 seconds, 30 minutes, and 41 minutes for teasers. And sorry, for smarts. And for teaser, minimum value is 12. Minimum value is 12. Let me encircle this with different ink. 12. Then the lower quartile, lower quartile is, I can show you, it is lower quartile is third position. Third position, this is Q1. Okay, Q1. Then median is, median will be sixth position. Okay, that is 12 over 2 means sixth position. Then third quartile will be your 3, 6 and ninth position. Ninth position will be your upper quartile, then maximum. Okay, so sixth position is, this is lowest. It doesn't need to be shown yet, I'm showing. Okay, first, second, third, so it is the lower quartile. Then another three, 1, 2, 3. So median is sixth position means 25 minutes. Then another 3, 1, 2, 3. So this is, I mean, 37 is your upper quartile, and maximum is 39. Okay, so this is how we will write the information. Okay, so for smarts we got 9, 13, 22, 30, 41. Let us write there. So our smallest value of smart was 9 minutes. Okay, it is 9 minute, not with this ink. 9 minutes lowest value, and our lower quartile was 13 minutes. 13 minutes. Then our median was 22 minutes. Our upper quartile was 30 minutes. 30 minutes. 30 minutes. Then our maximum value for the smarts was 41 minutes. Okay, 41 minutes. Then for teaser. For teaser, the minimum value was, we have seen that it was 12 minutes. So 12 minutes. Then lower quartile was 18 minutes. 18 minutes. Then median was 25 minutes. 25 minutes. And our upper quartile was 37 minutes. And maximum value of time was 39 minutes. So that's all about all the information. Now we are going to draw the box and whisker plot. Okay, so this is what the box and whisker plots of these two teams. Now we have written smarts times of the team, time taken by the team members of smarts has been drawn above the box and whisker plot of the teasers. And look, there are 5 information we have inserted. First, lowest value, lower quartile, median, upper quartile, and maximum values. I didn't show you the video because at the time I was in off mode of video, because it took a little longer time, which will cause the wastage of your moments. That's why I didn't include that in video. Just I'm going to show how to write this, all these 5 information. Look at these 5 vertical lines in each of the cases. If I show line number 1, line number 2, line number 3, line number 4, line number 5, all these, each of these vertical lines starting from lowest to maximum value has been drawn. Then the inner 3, I mean lower quartile, median, and upper quartile has been made a box. This is how you can draw a box and whisker plot. After that, we are going to move on to the immediate next question. The immediate next question says make two comparison between the times for the two teams. Look, it's a very confusing. Actually, there is no precise information from the box and whisker plots, as we extract the exact information from other statistical values like, histogram, frequency, but here frequency table. Here we can assume looking at the median. If you look at the median of the members of smarts, let us see, the median is 22 for smarts, whereas median of teasers is 25, whereas it is 22 for smarts. That means the smarts took less time comparatively. So we can write the number one. They asked for two comments. Comment number one, the smarts are quicker. How did we understand? As I have told, it is not precise information but an assumption, as the median of the smarts club or smarts team is shorter or smaller. That's why the smarts are quicker. Then the second comment, they ask for two comments. If we look at this, the in case of smarts it start from the median, and in case of median, if you look at these values, the median lower quartile, this box is starting from 13 until 30. Okay, look at this box, these lines. Okay, these vertical lines, these three vertical lines, these are more consistent than these three vertical lines. This line as well as this. Look at this. If we look, we can easily say that these times are not consistent. So that means the sequence or whatever you tell, these are not actually consisting or regular. So we can write the smarts are the values of smarts, the values or the times of the smarts are more consistent. That means they are more consistent. That means their time difference um, among themselves are not so high, it is consistent. So that's all about the answer to the question of C from this question. So these are the solutions. So I think you have understood how to write a box and whisker plot, and the comment is always for commenting on the box and whisker plot. Always we will take, though this is not precise, the most accurate way to judge. Yet if we are to write a comment, we will look at the median. If median is closer, I mean to the left side, then that is actually quicker. So that's all about the solution to question number 6. Let me show you the first part, then the second part. I tried my level best to make you understand every tiny part of this solution, and may Allah bless all of us with the beneficial knowledge. Fi amanillah. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from probability and statistics. This particular question belongs to paper 9709/55 for the session May June 25. Let's read the last of all question of this paper. A darts club has 12 members made up of 7 men and 5 women. Every Monday, a team of 4 is chosen at random to represent the club in a competition. Find the probability that on a particular Monday, the team consists of 1 man and 3 women. Let's start the solution. So, here the concept we know is it is all about selection. So we are going to apply the concept of combination. Okay, so let us see how many selections can be made if there is no restrictions. So first of all, we will write number of total selections, number of total selections, total choices or selections, whatever you write, selections. Total there are 12. Okay, total number of members is 12, out of which 7 are men and 5 are women. So from 7, if we choose only 4, okay, from 12, if we choose 4, it is just 12 choose 4. Okay, then it is going to be 12 factorial over 4 factorial as well as 8 factorial. If we use our calculator, it will show 495 choices. Okay, then they have told to find the probability when the team consists of 1 man and 3 women. So their total number of men is 7. Out of 7, we will choose only 1. And out of 5 women, we will choose only 3 women. So let us write number of selections. Number of selections with restrictions. With restrictions. With restrictions with restriction, number of selections is equal total selection. Here we can use equal symbol. So here also we are going to use the same symbol, equal symbol. Okay, so equal to what? First of all, we will have to choose 1 from 7 men. Look at this, it is written total number of men is 7. From 7 we are going to choose 1. 7 choose 1, and out of 5 women, we are going to choose 3 women. So 5 choose 3 women. Let us do the calculation. If we keep on calculating, it is going to be, let me write just beside this, it is equal to 7 choose 1 is actually 7. Okay, you know, and 5 choose 3, we can be writing 5 factorial over 3 factorial into 2 factorials. You know how to write this. Let us calculate this. This is going to be, well, 5 factorial means 120. Well, let us expand 5 factorials. 5 into 4 into 3 factorial. I am doing it manually. Actually, you can use calculator for shortcut. So 3 factorial can be dissolved by the other one. So this is 2 factorial means 2. So 20 and 2, 20 divided 10. So it is going to be 70. 7 tens are 70. Well, now here there is a clue. We should not ignore the question. Question didn't tell us to find the number of selections. If you look at this, it is actually find the probability. They have told us to find the probability. So for probability, it's very simple. We will divide the number of selections with restriction divided by with no restrictions. So let us write the probability. I think I can write just over here. Okay, hence probability is equal to, if we write, hence probability is equal to probability is equal to, we will just divide the number of selections with restriction by number of selections without any restrictions. So it is 70 over 495, 49 as well as 5. So finally our probability is going to be, if we use our calculator, we will get 0.1414. That means if we round it up to 3 significant figures, it is 0.141 equal to 0.141. So that is what the answer to the first part. This was actually very simple question. Let's move on to the immediate next question. The immediate next question says that every Tuesday, the darts club chooses three teams of four. Each team enters a competition in a different town. In how many different ways can the team be chosen if there are no restrictions? Look, this question is also about selections. Look at this number of ways means it is also about selection. So for selections, we know we are going to apply the concept of combination, not permutation at all, because arrangement is not sought here. So there are three teams, and each team will contain four members. So simply we can write number of selections, number of selections, number of selections is equal to, look, there are three teams, each team will contain four members, so total number of members is 12. We know 7 plus 5 12. So out of 12, in the first team we are giving four members. Then there comes the second team has already four has gone away, so there remains eight members. Out of eight we are choosing again four for the second team, and for the third team actually there are only four members, out of which all of them should be chosen. So it is going to be, if we write 12 factorial over 4 into 8 factor 4 factorial into 8 factorial, first quantity. Then second one is 8 factorial over 4 factorial into 4 factorial. You know how to write this, into 4 choose 4 is actually 1. Okay, you know this. If equal number of member or object is chosen from total is 1. Then if we use our calculator, let us use our calculator. It is 12 factorial over into 8 factorial over 12 factorial to 8 factorial over 4844. 4844 we will divide by 4844. So 4 factorial into answer is going to be 34,650 ways the three teams can be chosen. It's there is nothing difficult to understand this. I believe that all of you have understood both of the solution of this page, because these are the two of the simplest of all solutions. Okay, well, let's move on to the question number C. Question number C is printed on the next page. Yes, it is number C. So for C, we will have to find in how many different ways can the teams be chosen if each team must contain at least one man and at least one woman. So there we should not forget that in the previous one there were three teams. Actually, we are still under the question of this one. We are under these statement. Okay, this is our scenario. Every Tuesday the darts club chooses three teams. Remember, there will be three teams of four. Well, now for these one, three teams of four. So how many ways different, in how many different ways there will be three teams, and the condition is at least one man and at least one woman. So let us find the probabilities. Let us write total team 1. Suppose this is team 1, T1, then team 2, then team 3. There are 3 teams. Okay, so for the first team we can choose, suppose there are 3 men, as there should be total 4. Remember, we should not deviate from the question. They have told in each team there will be total number of members will be 4. So if 3 men, then there will be one women for the first team. And for the second team also we can choose, so 3 men and 1 women. Okay, then for the third team, let us see how many are left. Total there were 7 men. Out of 7 men, 3 men plus 3 men, 6 men have already gone away, so there remains only 1 man. And out of 5 women, 1 plus 1 2 went away, so there are 3 women. So this is the first case. Okay, so for the second case we can choose 2 men and 2 women. Okay, for the second team also we can find 2 men and 2 women, 2 men, 2 women, so 4 4. And now let's see how many are left. Total there were 7 men, so out of 7, 4 has been chosen, 3 is to be chosen here. 3 men and 2 plus 2 4 went away, only 1 woman is left. So these are the 2 possible cases of the selection. Now we are going to write, hence number of selections, but I can write just beside this number of selections, it can be written here. Look, first there are how many men are there? There are 7 men. Out of 7 we have chosen 3, so 7 choose 3, 7 choose 3 into 1 women, 1 out of 5, so it is going to be 5 choose 1. We have chosen 1. This is for the first team. Please don't forget that we will have to form all of the teams simultaneously. That's why it is multiplication, not or, remember. So for the second team, it was for the first team in the first possibility, so first team. Well, for the second team, as we are forming all of the teams simultaneously, so it is multiplication. For the second team, 3 men out of 7. So 7 choose 3, and sorry, it's not 7 because already 3 men has been taken. So it is not 7 men left. There are only 4 men left. So we'll have to write 4 choose 3. This is for the second team. Please don't get deviate from the fact. Then there is 1 woman. Out of what? 1 woman has gone away from 5, so there remains 4. 4 choose 1. Second team has, this was the first team and this is the second team. Then for the third team, how many men are left? 3 plus 3, 6 went away. There is only one. Oh, sorry, 6 has gone away. So there remains only 1 man. So from 1 we are choosing 1. 1 choose 1. And let's see women. So 1 woman, 2 women went away. So there remains only 3 women. And out of 3 we have chosen all 3. So it is 3 choose 3. 3 choose 3. So this is the third team. Please don't get confused with this. This is the calculation of first team, second team, as well as third team. Well, let's see whether I do have space on the right side or not. Okay, I don't have space for the in the right side. Okay, for the second possibility, let us write for the second possibility. For the second possibility, let's see first team. So for the first team, what is it going to be? For the first team, total there are 7 men. Out of 7, we have chosen 2. So 7 choose 2 into, this is for the first team. 7 choose 2 and 2 women out of 5. Out of 5, we have chosen 2. First team has gone away. This is the first team. Then second team. For the second team, we are choosing already out of 7, 2 has to have gone away. So it is going to be it is going to be 5. From 5 we will choose again 2 men, then women for the second team. For the second team, this is for the second team. Okay, so 2 women, already 2 have gone away, so there remains 3. So it is going to be 3 women. From 3 we are choosing 2 women. Second team has gone away. Now this is the third team. Okay, for the third team, okay, let's see what are left. 3 men are left. Actually, there are 3 men left. So out of 3, because 4 have gone away, so there remains 3 men. 3 out of 3. 3 out of 3, and there is only 1 woman left because 2 plus 2 4 went away. So there will be 1 out of 1 choose 1 into 1 choose 1. So these boxes indicates, look at this, let me form the boxes. This is for the third team, and this is the second team, and that is the first team. Same, so is in the first possibility, this is the second, and this is the third team. Remember, this is one of the most twisted question of this paper. Then then we are going to write the solution. Number of selections. Okay, so number of selections, let us write number of selections. Number of selections, okay, is equal to, first of all, let us write 7 factorial into 5 factorial. 7 factorial into 5 factorial. Then the denominator is going to be 3 factorial into 4 factorial. 4 factorial into, I am avoiding multiplication symbol, you can use if you wish. Then 1 factorial into 4 factorial. This is for the first team. Okay, I am just ignoring multiplication symbol due to the shortage of space. Then for the second team, it is 4 factorial as well as 4 factorial is numerator. 4 factorial into 4 factorial. Denominators are 3 factorial into 1 factorial. Okay, here we skipped one important uh, concept, which is, look at this. In the first team, if we look at the first team, we have chosen, this is the first team. First team can go, look at this here, this team can go, sorry, this team, the first team can be in the third case, and third team can be second case, and second team can be in the first place. That means in 3 different ways they can also be chosen. So we will have to multiply by 3. Okay, so let me change the ink. So we have forgotten to multiply by 3 because there are 3 vice versa. They can interchange their position, but don't get confused that this is not arrangement. But first time we can choose 1 man 3 women, and second time we can choose 3 men 1 women. That means in different ways, in 3 different ways you can choose the teams. So is the second cases. So 3, in 3 different ways their teams can be selected. Well, we are in the second teams. 4 into 4 factorial, 3 factorial into 1 factorial, 1 factorial into, please don't get confused, I am avoiding multiplication symbol as I don't have sufficient space to write, that's why. So 3 factorial into 1 factorial, and 1 factorial into, again 3 factorial into 1 factorial, because they are virtually same. 1 factorial means 1, I am avoiding that. Then for the next case, third team, look at this. From 1, if we choose 1 man, that is only one way, and from 3, if we choose 3 women, that is also one way. So there is no necessity of writing 1. So it is actually 3. Okay, then we will write the result. After that, for the second case, okay, plus we will add up this plus, it is 7 choose 2, so 7 factorial and 5 factorial into 5 factorial, so it is 2 factorial into 5 factorial for the first one, and 2 factorial into 3 factorial, 2 factorial into 3 factorial for the first team. Then the second team, 5 factorial, numerator is 5 factorial into 3 factorial, 3 factorial divided by 2 factorial into 3 factorial into 2 factorial into 1 factorial. I am avoiding writing 1 factorial because 1 factorial means 1, 2 factorial means 2. Okay, then third case is as same as the previous one. From 3, if we choose 3, it's 1. If we choose 1 from 1, it is 1. So we are avoiding that. Just it should be multiplied by 3, because we know that if the first team can be chosen in the third case, third team can be chosen in the second case, or second team can be chosen in the first case. So there are 3 different ways of selecting the teams. Well, now we will use our calculator. 7544 is the numerator. 7544, 7544. Okay. Denominators are 3414. So 34433. Oh, there is one 3 in the numerator. Let's not avoid this 3 in the numerator. There should be a 3 into 3 into. Let us be sure of the denominator. It is 34433. 34433. 34433. So this is 3 factorial, 4 factorial. Three factorial, 4 factorial, 4 factorial, and 3 factorial. The 2 threes and 2 fours. So in denominator there will be 1, 3, 2, 3, 3, 3 factorials and 2 4 factorials. Okay, so 3 factorials, 3 factorials. So there will be another 3 factorial. Number of choices is 8400. Let me write this 8400. 8400. Well, then the second case, if we do addition, there will be addition symbol, and it is going to be, well, 7 factorial, 7553 are the numerator. 7553, 75, then again 53. Numerators are 2 5 2 3 2 3 2. That means how many twos are there? 4 twos, 2 threes, 1 5. So 4 twos. Actually 2 factorial means 2. So it will be 16. 4 twos are 16. Then 3 threes are 6, 6, 36. Okay, let us write 4 twos, 2 threes, 1 5. Okay, 4 twos. First of all, we will divide by 4 2 factorials. So this is 2 factorial. Again, 18,900. It is 18,900. 18,900. So no number of total selection is going to be equal to what? If we add up 18 plus 8, that is 27,000. It is going to be 27,300. 27,300 is the total answer. Remember, as I have told, this is the most complicated part of the solution of this paper. So please be very careful. The maximum possibility of making mistake is here. You may forget to multiply by 3. Remember, these 3 should be, because 3 different ways the teams can also be selected. That's why both the selection should be multiplied again by 3. Well, let's move on to solution number D. D says the 7 men stand in a line for a photograph. 2 of them are brothers, George and Harry. How many different arrangements are there of the 7 men in which there are exactly 2 men between George and Harry? Okay, this is not difficult at all. First of all, we will have to write George and Harry are 2 brothers. So let us see G. Then in between them there will be exactly 2, and then there comes Harry. So 4 members have already gone away. There remains 3 to be 7. Okay. So number of arrangements, we can write number of arrangements. Number of arrangements is equal to, look at this, total except George and Harry there are 5 members. So 5 factorial ways they can be arranged. 5 factorial ways. This rest of the 5 members can be arranged. After that, look at this. These G and H, George and Harry, they can also interchange their position 2 different ways. So 2 factorial. Now, if we make a box of this, suppose this is a box. Okay. So this position can be, this box can be over here, there, as well as there. Okay, so total there are 4 possibilities of changing their position. So let us multiply by 4, not 4 factorial. Remember, this is just they can change their position in 4 ways, not 4 factorial. So 5 factorial means 120. 2 factorial means 2, so 240. 244s are 960. So there are 960 ways of arranging them. This is a very simple question, you know. For arrangements, we apply the permutation concept, and we did so. So these are all about these 3 solutions of this question. Among these 3, again I'm repeating that number C is the most complicated question, most twisted question. Let me show the first part once again. So thank you all for being with me, and may Allah bless all of us with beneficial knowledge which will make each and every person of the world knowledgeable, especially in maths and science. Fi amanillah. Let me show the next page.